the idea here is that the ideal point, you can imagine, suppose you could imagine the best of all possible worlds, right? So the sort of the best possible score on all the criteria. And then you ask which of your alternatives comes closest to that. Okay? So imagine, for example, that we were looking just at two criteria. What criteria do we want to think about? What are you guys thinking about these days? All right, A and B. And we have, yeah, and they're each on some score, some scale, and let's say they've been rescaled to be between 0 and 1.
I saw a good one that is coolness and practicality.
Okay. And what was this in reference to?
This was a TED talk. They were talking about some project. It'd be very cool, but very impractical.
Okay. And so we have a bunch of alternatives, and they have different scores. And suppose that, just for the sake of simplicity, that we have scaled, or that our weights for coolness and practicality are equal. Okay. And so remember then that with the multi-attribute value theory, right? We would just take these scores, multiply them by the weights, and so whichever one scored at essentially the highest sum of coolness and practicality would come out as the best, right? And let me add a few points here. So in fact, these four alternatives would actually have, if that's a negative 45-degree line, would actually have the same score on the multi-attribute value. So now let's imagine, okay, what's the best of all possible worlds, right? We'll say, well, it could be really cool, and it could be really practical. And we could just say that that our ideal point is 1, 1, right? Or we could say that none of these actually reach 1. It could be 0.9, 0.9. It could be whatever the maximum value that we observe in our set for each criterion. Okay, and then we ask, what's the distance between each of these points and our ideal point? Okay, so how do you measure distance?
I guess this way.
Okay, so the standard way to think about distance is, let me make sure I use the notation I'm going to use later. So if this is, we'll call coolness is V1 and practicality is V2, and then this ideal point we'll call V plus. standard Euclidean distance. And if we didn't, if the weights weren't equal, right, more generally, we would include in here Wj squared. Okay, so that's the way to sort of that's the piece to rescale it by the weights. Okay. And so this is our sort of standard notion of distance. And one thing to notice here is that these 4 points that have sort of equal value from the multi-attribute value score are going to have different distance scores, right? This point is closer to the ideal point than this one is, according to this distance metric. Okay. Now, is this the only way to measure distance? What other ways are there to measure distance? Forget about this. Think about distance and geographical distance. If you're in a city, is this a useful way to measure? Is this a useful way to measure distance?
You have to navigate through some pathway or some option set or something.
Right. So in a city, for example, with a rectangular block system, right, then the distance is actually going to be, whatever zigzag path you take, it's actually going to be, that plus that, right? And so that's, and so that would be, instead of squaring and taking the square roots, you would just sum those values, okay? And in fact, in general, you can, if you talk to mathematicians, you can generate, or they talk about a whole family of distance measures, which would be like this, but instead of the squared, we just take an arbitrary exponent p, which can be, and then p, and then the pth root of all that. So when p equals 2, right, this is Euclidean distance. When p equals 1, then we get this city block distance. In the limit as p goes to infinity, you get whichever coordinate is largest, right? It goes to you sort of get the max. The limit that just gives you the maximum distance across all the coordinates. And typically, the effect of as we increase p, all else being equal, where it forces us is that all else being equal, we're trying to minimize the variances among the different coordinates, right? So, if we had a bunch of points that had this distance being the same, the stair-step distance being the same, but when we go to the Euclidean distance, that's going to privilege points that have that are closer to being on a 45-degree angle, right? Where these two components of the city block distance are similar, right? And the higher p is, the more it privileges that convergence. So it's kind of a higher p is kind of equalizes among the criteria.
P, the number of steps?
No, p is just an exponent. Okay.
Doesn't represent number.
No, I mean, so when p is 2, it represents that we're doing Euclidean distance as opposed to a stair-step distance. But you can do this calculation with p equals 3, right? It's hard to envision what that means, but you can do it. Yeah.
So I guess like practically, like the practical interpretation of the stair-step distance would be, you had to choose, I mean, it's like, there's some choice that, there's some trade-off that would give you maximum increase in coolness versus Euclidean distance. So that means like the next option.
Right. Well, so if we think about P equals 1, so the city block distance, right? What we're saying is it doesn't matter whether we get a, suppose, this is, 0.1 and 0.1, right? We would get the same score if from here this whole thing was 0.2. Okay, so it's basically saying we just want to we're just 0.2 units away from the ideal point. We're not going to distinguish how that 0.2 units is distributed among our criteria, right? Whereas the Euclidean distance is going to say I'd rather be at a point where my deviations from ideal are kind of are distributed across my criteria more or less uniformly.
Right. Assuming that there's equal weights.
Right. Well, that's why. Yeah. So the weighting. That's why the weighting term is in here. So this is actually going to take care of that scaling. And it's just the more you crank up P, the more you care about that sort of equity among criteria. Okay. So this is. So this is the distance to the positive ideal point. We can also talk about the distance to the negative ideal point. Now, if the negative ideal point is at 0, okay, and we're using a P of 1, then the distance to the negative ideal point is actually going to be just the same as the formula we would use for the multi-attribute value theory, right? It's just going to be W times the value minus 0. Sum those up, okay? But if we're using a Euclidean distance, or if our value point is here, right, something above 0, then the distances to the negative point are not going to be exactly the same as the ranking we would get from the multi-attribute value theory. So similarly, we can calculate the negative distance is just very comparable. It's just that we are using a different ideal point. Okay, and so the idea is we want this positive distance to be as small as possible, right? So if we try to find the solution, the alternative that minimizes SI plus, we're saying we want the solution to the alternative that's most good, right? And then if we maximize SI minus, right, that says we want the alternative that is least bad. Okay, and they're not necessarily, depending on where these ideal points are and what distance metric you're going to use, they're not necessarily going to give you the same ranking. Okay, I mean, on a broad sense, they are. I mean, just, you're going to tend to end up with these alternatives coming out at the top and these alternatives coming out at the bottom. But the exact ranking may well differ between one and the other. And so a particular implementation of this technique called topsis, I've got one of these lovely acronyms. Let me see if I can. Technique for order preference by similarity to the ideal solution. And what they do is they calculate. They basically say they combine these two measures by calculating what they call the relative closeness to the ideal point this issue of when you're rescaling things, saying between 0 and 1, how you go about doing the rescaling might matter. And let's look at another example today. It might matter in the sense of if you're just always comparing it to a reference point of 0, which is what implicitly the multi-attribute value theory is doing. Right? It's essentially, multi-attribute value theory is calculating SI minus with a P of 1. And so this on the one hand, it allows you to be aspirational by having a positive objective instead of a negative objective. But it allows you to think about that positive objective in the same set of scaling. This doesn't make any sense, is it? I think I'll stop trying to confuse you about this. It gives you different results than multi-attribute value theory. It sort of comes from a different way of thinking about the problem. But and so depending on the extent to which you want to sort of impose economic rationality on your decision makers, or if they're comfortable with the model of economic rationality, then multi-attribute value theory is good. But this is a way that is perhaps more appealing, especially to non-experts. They can say, well, how close am I to my idealized solution? And this is a method I think that is true. Maybe you can have some knowledge of this, but what my reading says that this is often used in spatial prioritization problems. You haven't seen this?
Sorry.
Okay.
Does anyone draw the link between this and utility or indifference curves in economics? Because basically what you're doing there is depending on your value of P, you're just defining the shape of your utility curve.
Mm-hmm.
The value of the high value of P, you have very convex preferences, and with a value of P of 1, you have linear preferences.
Right.
And I mean, in economics, all you do is you once you figure out your utility function, you just maximize utility subject to your constraints.
Mm-hmm.
Is that? I mean, it seems like it's very similar. Is anyone drawing a link between the two?
Possibly. I certainly haven't read all the literature on this, but not that I've come across.
It just seems like you have a discrete choice set, right?
Yeah.
And that you could do some sort of optimization. And simplex would give you one of those choices. As long as it's convex.
Yeah, but it also depends not just on this shape and on on the curvature of your utility function. It also depends where your reference point is.
Right, I guess that's the move.
You have to so this is setting a reference point and a way of mapping the utility function to that reference point.
Again, it's kind of the same thing though, because if you were to, I mean, we just said that you set the reference point on a 45-degree line, which I think is, if your weights are the same, then that ends up being true. If your weights are different, then it'll skew your reference point down or up. But either way, I mean, the same could be said of utility curves, and they don't have to be on a 45-degree line.
Right.
They could be skewed like this, and then they could be, some sort of some sort of curve that is curved one way or another depending on. I guess it's saying depending on where your reference point is, but really it's depending on your indifference between the trade-offs of the two different criteria. Right?
Yeah, so maybe this is just a practical way of doing that without having to teach the decision makers about
Utility function.
utility theory.
And the result is the same, I feel.
Yeah.
If you're going for the SI plus, trying to maximize your decision as opposed to minimize the bad.
Yeah.
First, I just thought a very simple use of this in GIS. I was going over the summer, trying to identify like distance to estuaries. So I just did basically Euclidean distance from all the points around it on a map, and then we assigned a score. If it's within 500 yards, it was a 2. If it's from 500 to 1,000, it was 1, and then if it's more than 1,000, it was irrelevant, so it was 0.
Right.
With a P of 2.
Right. So that's a way of assigning scores.
Yeah.
Right.
But before these scores, we're just doing the Euclidean distance just to calculate all the points that would fall under different.
Right. But then you were So but it's actually it is slightly different because you were using Euclidean distance to transform a spatial measure into a categorical score,
Yes.
which then you could put into a multi-criteria analysis.
Yeah. Like a brace stack.
Yeah. So So doing. So it's actually a different thing. Right? This is distance in this attribute space as opposed to distance in real space. Okay. So that's all I wanted to say about that. The next thing I want to talk about, I just was reading this week the latest issue of Nature Climate Change. So we're switching now to talk about, instead of methods, to talk about values. And there's an interesting, it's really more of it's a commentary rather than an article, but it's talking about the difference between what they call extrinsic values, such as desire for fame and wealth and physical attractiveness, versus intrinsic values like desire for self-knowledge, emotional intimacy, and community involvement. Okay? And how people who have those different kinds of values, how they differ in their behaviors and choices. Do you have any predictions?
In the context of what choice?
Okay, well, in the context of how, first of all, how cooperative they're likely to be, how kind of environmental they're likely to be.
Stronger cooperators and stronger environmentalists.
Yeah. So there actually have been social scientists who've studied this and kind of measured their subjects' values on some scale that runs from being more extrinsic to more intrinsic, and then tested them with things like prisoners' dilemmas games that are sort of a measure of how cooperative they're likely to be. People with extrinsic values are less likely to cooperate in these games. And then when they sort of interview them about what they do in their lives, these extrinsic value people have higher environmental footprints. They care less about social and environmental problems. They're less likely to engage in political activity. Okay. So that's one piece of information, that people, these values, whether you care about kind of feeling values versus tangible values, affects what you do and what you do in the environment. But the piece that really makes this interesting is that your sort of tendencies, or an individual's tendencies, one way or the other, can actually be influenced. Okay, so they talk. There's two experiments they talk about in here. in the first one, there's, they bring in participants and are given some information to read about lifestyle choices, including car sharing. And some of them read information about the financial benefits of car sharing. And others read information about the environmental benefits of car sharing. And they're put in these two groups, Charlie Ray. Then they're given some other task to do, unrelated, that involves writing some stuff on a scrap of paper. And at the end of the experiment, they're told to dispose of the scrap of paper and leave. And by the door, there's a recycle bin and a trash can. And so the people who read about the financial benefits of car sharing were less likely to recycle the paper than the people who read about the environmental benefits of car sharing. So there's kind of a, you know, and they didn't, you know, since that was sort of that was the real part of the test, which of course the participants didn't know anything about. There was no post interviews, but that's, you know, there's at least in the short term, there's this kind of priming. And a similar experiment asked participants to reflect on different aspects of American identity without any mention of the environment. And then they were asked to imagine that they were advising their government on optimal ecological footprint. And those who were asked to reflect on extrinsic aspects of American identity, such as a country of enterprise and economic success, recommended significantly higher footprint goals than those that were reflecting on more intrinsic values. So at least in the short run, you know, individuals can be primed to be sort of more cooperative, more interested in the environment and in sort of social goals more generally. And to me, you know, when I read this, what really struck me is that it comes back to we haven't talked much about how you actually run a process where that has multiple decision makers or multiple stakeholders. But it's, you know, there's before you even start writing down alternatives and criteria, there's an important process of eliciting a sense of, you know, we're all in this together, in the sense of trying to make this decision and trying to find out what goals, if any, are shared. And this work suggests that if we're structuring such a workshop, it would probably be more productive to start with intrinsic goals and really focus on those intrinsic goals. And in terms of, you know, benefits to the environment, benefits to society, how does this affect our community, and to hold off on the sort of economic and financial goals and outcomes until later in the process. Because if we start with the economic and financial outcomes and objectives, that will tend to lead the individuals in the group to be, according to this evidence, less cooperative. And this ties, and this you know, this links with the presentation we did on AHP last week. And it said in there, it seems to work out better if we leave the discussion of costs until the end, rather than mixing it all in together. It's not just because costs are, you know, different because they're numbers and dollars. It may well be that they sort of trigger different aspects of our minds, right? And we are, you know, as human beings, we are both social and cooperative, and we're competitive and trying to achieve. And depending on which part of our minds is activated in a group setting,
company with a very nice product that's very high quality, that's very also very high price, and it's, you know, saves the price for last.
Mhm.
You know, whereas the other company that has sort of the mid-range product, this budget will emphasize the price at the beginning, sort of steer you away from the features that doesn't that.
But isn't that a way to bias the process? If you are purposely deciding what kind of information are you providing, you are being or partial, not impartial. So it's, I don't know how is the best way to go, and I guess it's depending on what is your goal for the group.
Mhm.
I was thinking the same thing, that it's an interesting ethical dilemma, because on one hand, as environmentalists, we have this ethical responsibility to do what we can for the environment, and maybe that means, you know, priming people to think more environmentally. But on the other hand, if our goal is really to elicit the true values of all the different stakeholders in the process, then priming them first with some sort of really a psychological trick of some kind, be it advertising or some sort of framing, then we're not really going to get their true, you know, maybe we'll get them to be more environmental and maybe they'll solve the first goal, but then are we being really true to the process and what we're really trying, you know, there's a tension there.
And you're taking the risk to be seen like you're advocating for something.
Maybe I'm not understanding, but it seems like even if your strategy is to get people to be more environmental, like I'm thinking about, I did advocacy for a while, and you know, if you were in a conservative, talking to a conservative group, it seemed like the recommended strategy was to focus on the economic benefits,
Mhm.
you know, to get more buy-in, rather than, you know, starting off with the environmental benefits.
Mhm. Yeah, it's an interesting conundrum, and I think, yeah, and what I just throw out there is, you know, a couple thoughts is, you know, what is somebody's true values? If my stated values can be so easily influenced, or, you know.
Presumably they lie somewhere in the middle of
Mhm.
both of those options, right? And they can sort of be slightly influenced either way,
Right.
and the truth lies somewhere in between. But
And sorry, and also when you decide where to put your paper, which being you are not actually risking anything, you are not deciding, you know, you are not losing anything, so you don't need to decide really carefully. You are not thinking just when you are in this kind of process, you actually really to put in the balance. And I don't think that the final answer is going to be similar to the decide where you put in the paper, because you are going to take time to analyze, or you should at least.
yeah, it's a different type of decision, for sure. Yeah, it seems like it gets down to like a nature versus nurture question, because like you're saying, like, are people's true values solely a function of the information that they have access to? Because otherwise, would they have some separate value that's independent of everything they've been exposed to? You know, so I think it's probably a combination of both. Like,
Mhm.
people have some intrinsic value system that's independent of the information that they're exposed to, but then you can sort of nudge that in one direction or the other by telling them certain things. Yeah, definitely in the short term for
Yeah.
low search effort sort of decisions, like where do I put my paper?
Yeah.
I think all sorts of decisions, probably more than we really realize, are affected by outside factors. Like anyone who's ever gone grocery shopping while they're hungry knows that just, you know, whether or not you've eaten before you go grocery shopping can make a big difference on how much stuff you put in your cart. Like, what's the true amount of things you really needed to put in your cart? It was probably, you know, not quite what it was. And so just like that, if you know, go to this stakeholders meeting just after you've gone through a walk in the, you know, on a trail, you might have different, you know, a different perspective going into it, regardless of what, you know, information they present
Right.
first or second.
got a really interesting article on during the summer. I think I still have the link. I can send to you guys. But it was basically it was about decision fatigue. So as you go through your day and you have to make a ton of decisions, and then by the end of the day you're kind of stressed out, and then you're less likely to take any risks, and that's when you get like the chocolate stuff that you've been avoiding all day. And it cited a couple of studies, kind of. It started with some judges at the end of the trying to see if some folks would go on parole or not.
Like
based on
after
their
lunch
behavior.
before lunch.
Guilty.
And they had like 3 cases, and they're exactly the same. And the first guy that got in at 8 in the morning got parole, and then the other 2 guys didn't. And then it's kind of interesting.
Yeah.
Even in the morning, if you're making a decision in the morning, it's going to be different than if you're making it at the end of the day, depending on how your day went. Kind of thing.
Yeah.
It's a true value thing.
So the other thing that this speaks to, so it is that, so we could say we're priming the pump to make people more environmental, and that might be a sign of bias. But it's also, if we think back to the first example and how values affect cooperativeness in general. If our goal is simply to have a more productive group process, the cooperativeness potentially goes both ways. It may be that the environmentalists become more willing to compromise if they're reminded of their intrinsic values.
So you probably need to put it apart and start with econ or environment, depending on the group you.
Well, if you're trying to influence the outcome, yeah. So your point about the recommended way to deal with conservatives when you're going out and talking to them about environmental issues. I wonder if that actually works.
Yeah. I mean, it seemed like just to get people to listen to you in the first place. That I think that was the rationale, but maybe ultimately it's not really the best strategy.
I'd say they're working if there are clear financial benefits. I think that'll be an easy sell. So, hey, you can save money.
Right.
Really does. But if it's kind of on the balance, maybe.
Yeah, well, so the suggestion in this commentary is that if you focus on the financial benefits, even if they're substantial, you're putting that person into a mindset of being selfish, which in the long run may not be as helpful as putting them in a mindset of being cooperative. And again, the broader context of this commentary, given the journal it's in, is about how we should talk about climate change.
It'd be interesting to see if that similar finding holds with higher effort decisions. Because I can see certain stakeholders, corporate lobbyists, like their corporations in general exist to be selfish. It's not a fault of theirs. It's just that's their purpose in one sense. So I don't know how many pictures of pandas you show up before the meeting. I don't know if it's really going to convince them to be any less selfish. At the end of the day, they're still thinking about the income statement.
But you are not going to the corporation. You are going to the people representing the corporation.
But they're paid to.
No, sure, but you can influence people. You cannot influence corporations. Even now, corporations are individual.
But if I don't know, if it's a person acting on their own behalf and forwarding their own values, that's one thing. But I feel like people in those positions are generally pretty good at separating, okay, this is the corporation's values and this is who I'm representing right now versus, maybe not, I don't know. But it'd be interesting to see a study that involves more involved decisions than just paper things.
No, that's true. Yeah, that's drawback of these kind of psychological studies. They probably were mostly college students too. Yeah. So that's kind of a basket of topics for today. The next thing I wanted to bring in just were some other ways of eliciting values and criteria but suppose you ask somebody, you know, how much, you know, what's your preference for A over B? What's your preference for practicality over coolness? And they say, well, I don't know. I've never thought about it. And so one way to help them think about it is to do a trade-off analysis. And so if you, so you essentially say, let's see, here's the example. So suppose you were, just to make things look a little different. Suppose we were evaluating a set of properties to build a house on. Okay, the two criteria that we're interested in at the moment are price and the slope of the land. Okay, obviously we would expect that, you know, building on a steep slope is difficult, and so we should only do that if the land was somewhat cheap, right? And so what is that trade-off between steepness and cost? And so if we were to say that, you know, if for example, if the set of properties we're looking at range between $50,000 and $500,000, and let's say we will map that onto a scale that goes from 0 to 1, and slope range from flat to say 15%, and again we say 0 and 1. Okay, so we would basically, the trade-off analysis, simple version of the trade-off analysis, it says that let's take one extreme, let's take an imaginary site B that has a price of 1 and a
Shouldn't be 1, 0.
sorry, yeah,
It's practical.
flat is good.
The price should be the other way around, right?
Yeah. Price is no. So high price. So we're actually we're not just adding them. So high price and flat slope. So 0 is good,
Okay.
right? And 1 is bad. Okay. And then another site that has, say, a slope of 1, so a steep slope. And and you say, well, suppose the price of A was 0, really low, which would you prefer? Okay, and you might say, given a choice between these two alternatives, well, I choose A. And then suppose the price was 4.4, and the slope was 1. You think about it and say, well, I'd still choose A. And then if the price was 0.8 and 1, and say, well, no, I'd rather pay the extra for the flat. And then you sort of back up and say, well, what about 0.6? And then say, well, I could go either way. Okay, so you sort of find out, you sort of just, by making this concrete set of comparisons, you kind of guide the person through working out what their indifference point is between price and slope on this scale. Okay, and then so then you could say, given this scale for price and slope, then we would say that the you know that the weights would be that we we accept a 0.6